Alright, so I'm going to go over this whole review with you in a series of 3 to maybe 4 videos, depending on how long it takes. So this first video, we're going to get through the first two big learning targets here, and then we'll stop after that. So, for 1 through 8, fill in the blanks with the correct word or phrase. A system of linear equations is 2 or more linear equations together, right? So, keyword there, system, means 2 or more. What we've seen is mainly 2. A solution to a system of equations is an ordered pair. Okay? When graphing, the solution to a system of equations can be found at the intersection point, or intersecting or intersection point on the graph. Parallel lines have equal slopes or same slopes and different y-intercepts. Because they never intersect, they have no solutions. Coinciding lines, or same lines, have equal slopes and equal or same y-intercepts. So the difference between parallel and coinciding is not the slopes. The slopes are the same on both of them. It's the y-intercepts. Because the same lines touch or meet everywhere, they have infinitely many solutions. Intersecting lines have different slopes. If the slopes are different, that means they are going to intersect or meet and have one solution. Perpendicular lines, okay, a lot of people get confused by this one. Perpendicular lines intersect, right? They intersect. They're just a special type of intersecting lines. So perpendicular lines have one solution. The 3 methods for solving a system of equations are graphing, substitution, and elimination. And this video here, we're going to talk about the first one in graphing. So I can solve a system of equations by graphing. So basically this is a review in how to graph lines, okay, and then interpreting your answer at the end. So both of these equations right here are in slope-intercept form. So I can go ahead and graph them. The y-intercept is -1, so go down to -1 on the y-axis. Up 3, right 1. So up 3, right 1. And I'm just going to repeat that over and over again. Now I just did a couple points down here. Up 3, right 1 is the same as down 3, left 1. You can see that by the fact that all those points are on the same line. Next line, also in slope-intercept form, goes up to 3 on the y-axis, so 1, 2, 3. And then negative, that's like a -1 over 1, so down 1, right 1. Down 1, right 1. I see that those are already meeting, so I'm just going to stop right there. The intersection is right there. That point is on both lines. That's my solution, which is 1, 2. And if you want to check, that's the nice thing about systems, you can check them. Put 1 in for x, you should get 2 for y, for both of them. 3 times 1 is 3, minus 1 is 2. -1 times 1 is 1, or -1. -1 plus 3 is 2. There you go. Number 10, -2/3 x plus 7. That one's ready to go. We go up to 7, and we go down 2, right 3. Do it again. There's my lines. Okay? Or my line, sorry, first one. Second one's not ready to go yet. That one is in standard form, but I need to put it in slope-intercept form. So I'm going to subtract 4x. I'm going to get 6y equals -4x plus 12. Divide everything by 6. I'm going to reduce this right away, so that's -2/3 x plus 2. We go up to 2, down 2, right 3, down 2, right 3, up 2, left 3, up 2, left 3. Okay, those lines look parallel. Now notice what I said, they look parallel. They don't meet on the graph, but to make sure they're parallel, we need to look at their slopes and y-intercepts. So slopes are the same. So parallel lines have same slopes. So they have the same slopes, and their y-intercepts are different. So they are parallel, so therefore there are no solutions. Okay. Number 11. First one's already in slope-intercept form. I'm going to go ahead and graph it. Up 2, up 1, right 2. Down 1, left 2. Next one is not in slope-intercept form. Got to get it there. Subtract 2x. So 3y equals negative 2x minus 15. So y equals negative 2/3 x plus negative 5. So negative 5 down 2, right 3. Now you can see that that's not, neither one of those points is on that line. So I'm going to go that way to get more. Instead of going down 2, right 3, I'm going to go up 2, left 3. I'm going to put the negative with the bottom. So up 2, left 3, up 2, left 3. There it is. Found the point that they both share. It's right there. And that is the point negative 6, negative 1. And again, if you wanted to, you could put negative 6 in for x and negative 1 in for y and see if they work for both equations. I'm not going to do that in this video, but you can do that in general. Okay. Number 12, first one's in standard form. I'm going to move that right away. So I get negative 2y equals negative 6x plus 14. Divided by negative 2. I get y equals, a negative divided by negative is a positive 3x minus 7. Down to 7, and I'm going to go up 3, right 1. Second line is in slope-intercept form. Oh look, it's the exact same line. So it would be literally the exact same points. So the solutions here, well, they're the same line, so there are infinitely many solutions. Okay, so I will stop there for first video. The next video we'll jump into substitution and maybe some elimination.